Okay, for each problem, approximate the area under the curve over the given interval using 4 left endpoint rectangles. So this process is called Reimann sum, and I think it's spelled like this. So before there was calculus, this is how we did things. So if you had a graph like that and you were concerned with this area, what you'd do is you'd create, and more than this, I'm just giving you an example, but there would almost be this infinite number of rectangles, and then you'd find the area of a rectangle under the curve, and that would kind of approximate. So there are 3 different ways to do it. There's the left endpoints, right endpoints, and the midpoints, and we're going to do one of each. So this is going to be a quadratic. So if we were to graph that, I'm going to pause and then graph this. Okay, so what I did is I just created a table of values. You can use Desmos, plug this in and see what the heights are when x is -5, -4, -3, -2, -1. And it looks like the vertex is right here when x is equal to -1. This right here is the vertex. Not that that matters in this context. All right, so what you're going to be doing is you're going to be finding the area under the curve. And what we're going to do is we're going to create a bunch of rectangles. And what we care about is the leftmost point. So when you're doing your table of values for the area, the leftmost point, so -5, -4, -3, -2. But notice the leftmost, this right here, -1, this part isn't going to really count because we're going from -1 to -2. This area is the area that's going to count. All right, so here's the process. We're going to count by units of 1, and we're going to draw a line. So look at that, creates 4 rectangles. Okay, so as we notice, this height right here at -5, the height is 9.5. So let's pretend that we draw a rectangle. We care about that leftmost point, but we're only going 1 unit. Well, 9.5 times 1 would be the area of that unit, which is 9.5 units squared. And we're going to do the same thing. At -4, we're at a height of 6 times 1 unit for that rectangle. And what we care about is the left height. So yeah, even though that part of that rectangle is not under the curve, this is just the process, but we care about this point. All right, so that's going to be +6 units squared. And at -3, we're at a height of 3.5 times 1 is 3.5 units squared. And then at 2, we're at a height of 2 times 1 is 2 units squared. And then you're going to add all of those units. So 9.5 plus 3.5 is 13. 13 plus 6 is 19 plus 2. The area under the curve is roughly, so this is one way that you could do it. You could say, since taking the integral, this is from -5 to -1, we can say is roughly 21 units. So, and then I'll leave this up here for a second to see what we did on this one. All right, and then we'll start another one. Okay, so this one for number 3 is a rational graph. I went ahead and pre-did it, have my table of values. We care about the values from 2 to 6, so I went ahead and put those heights in the table, right? So each of those, the rectangle is only 1 unit wide, so 2.5 units squared for that rectangle, 1.6 repeating, so maybe we put 1.67 units squared, 1.25 units squared, 1 unit squared, and you add all those up, and you're roughly going to get about 6.42 units squared when you find the area. So another way to do that, I just kept that as repeating. I would accept this as well. Another way to do that is do it like this. Okay. Now we're going to be using the rightmost points. So up here, the very far right point, we don't have to factor that in because we're only going by the left. Well, when we go by the right points of the rectangle, those heights, the top, the leftmost point, which is the top, is not going to count. So here I have this function, y is equal to negative x over 2 plus 4. So just a line going in the down direction. And what we care about is from negative 3 to positive 5. And we're counting, it says 4. Well, that's 8 spaces. So now we have to multiply these by units of 2. So if this height is 4.5, our width is 2, so this is going to be 9 units squared. And this is going to be 7 units squared, 5 units squared, 3 units squared. And I have those totals right there. And so that's one way to do it. Sum of the areas, to write it that way. And then the other way, whoops, not an equal sign right there. Just like that. Okay, now the next one I'm going to show you is using the midpoint. This kind of messes with students' brains a little bit more, and I'll show you why. So we just have another straight line going down. Our slope is negative 1, and we care from the units from negative 7 up to positive 1. So that's a space of 8. So we're counting, we're going to multiply those by 2. All right. So here's the dilemma. Notice halfway between negative 7 and negative 5 is negative 6. So we're going to care about all these midpoint x value. So negative 6, negative 4, negative 2, 0. And then we're going to multiply those by a height of 2, which is what I did down here. So if we said and we better put, this is from, the lower bound is negative 7, the upper bound is 1. That's going to roughly be about 64 units squared if I did the math correctly. Because what we're doing now is we're taking the height of the midpoints. Okay. Okay, so now we're back to what if we don't have the graph? We just have the table. Well, if it's the left hand, we just cross that off. And then what you're going to notice is between 0 and 1, that's a length of 1 unit, right? And what we care about is the left height. So this is the left height, left height, left height, left height, right? But here's a dilemma. From 1 to 4, that's 3. From 4 to 8, that's 4. And from 8 to 10, that's 2. So notice these lengths of the rectangles, I showed them right here, are these values right here. So you take these heights and match them up. So 1 times 4, 3 times 5, that looks like an S, but that's a 5. 4 times 6, 2 times 7. And when you multiply each individual term, then add up the sum, you get roughly. So another way to do that is we're going from 0 to 10, and you just say f of x dx is roughly 57 units squared. Again, because we're talking about the area underneath the curve. So area implies units, or not implies, requires. Okay, this one is the right hand. So now we're not going to care about this. So this is the right, oops, the right, the right, the right, right. Well, except for those are the x values. This is the right height, the right height, the right height, the right height. Now, from 0 to 1, that's a unit of 1, it's a unit of 3, a unit of 3, a unit of 1, and that's what we did over here. So 1 times 8, 3 times 7, 3 times 5, 1 times 4, and then this is one way you could write that, probably a better way. All right, this is a Reimann sum kind of methodology. All right, now we're going to get to definite integrals, and I've given some examples, but in the video, I'm going to go ahead and end here, and that'll be called Reimann sum video, and then we'll get to this.